So, you've got a NetCDF file and you want to plot the data inside it using R. In this video, I'm going to first show you how to create a line or a scatter plot of some one-dimensional variable. In this case, it's going to be a depth profile, but you could have a time series of data, for example. And then we're going to overlay some data on a map to produce something like this. And of course, throughout this, I'll show you how to customize these plots to make something that suits you. I'll put a link to the code accompanied by some explanations in the description below this video. And I'll also provide links to the data that we're going to use in this tutorial, as well as recommended citations for each of the datasets that you can use in your list of references if you use these data in your own work. So let's get to work. We're going to start by loading in the libraries that we're going to use today. So we're going to use the library NetCDF. And also later when we're getting onto the map data, we're going to use the library ggplot2. If you haven't used these libraries before and you need to install them, make sure you do that first. Something like install.packages rnetcdf, and the same for ggplot2, of course. In this case, I've already got this installed. We're going to start by working with a depth profile of chlorophyll A data, and I'm going to put a URL here to the OpenDAP link for these data. So I'm going to copy this in. I'll put this link in the description so you can copy it from there. Basically, OpenDAP allows you to access data over the internet without having to download the data to your own computer first. I discussed this in a bit more detail in the first video within this playlist. So if you want to learn more about that, and how to open a NetCDF file and access different components of the data or metadata, you can go and watch that. I'll also put a link to that in the description. So let's load the data in now. So we can just do data and make that equal to open.nc and our URL. And I want to have a look at those data, so I'm going to do print.nc data. So if I run all of this, and let's expand the console below and scroll to the top. I'll go through this briefly because I explain how to open up and understand different components of a NetCDF file in the previous video. But basically this file includes a depth profile of chlorophyll A data. You can see the variable here, chlorophyll A total, which has a single dimension depth. And from here, we can see that this includes 11 data points. We can look at the variable attributes, which are the metadata that describe the variable. So the units for the data are here, micrograms per litre. We have a long name, which is the data creator's own description of the variable. And we have the standard name here, which is taken from the CF conventions. So if I go to the CF standard name table and I search for that name, I can open this up, read the description, and understand exactly what the data are. And anyone who's creating a CF NetCDF file that includes chlorophyll A data should use the same standard name. So then we have consistency between datasets, and it also makes the data machine understandable. So back to R now. Let's first extract the data we're going to plot. So we need the depths. So I'm going to call that depth. We can do var.get.nc. Data is our NetCDF object, and our variable that we're trying to access in this case is depth, that you can see here. So depth. We also need for chlorophyll A, so I'm going to just call this chlorophyll A total, and that's going to be var.get.nc data and chlorophyll A total. Now let's create a very quick line plot. We can do that with plot. And I want on the x-axis my chlorophyll A total, and on the y-axis my depth. I try that, and we see a very basic scatter plot of the data here. Let's add some better axis labels, so we can do xlab equals chlorophyll A total, and we can do ylab equals depth. And we can add a title, which is main equals depth versus chlorophyll A, for example. Let's run this. Some of you might have noticed my typo, so let's run that again. And there we are. Now our depth is kind of upside down. It'd be better if 0 was at the top and increasing depth going downwards. So we can do that. We can just set the limits, ylim, and make that equal to some list. Now, we can just put some manual values in here like this. And that will run just fine if I remember to include the comma. But we can also derive this from our data as well. We could do, for example, max depth, like that. Let's say we want to create a line plot instead. We can do that. We can do type equals L. The default is P for point, so L is for line. Run that. We might want to set a limit for the x-axis as well, using xlim. Make that equal to, 0 to 7. We might want to flip these axis labels round on the y-axis. So we can do las equals 1. We can change the color of our line. So for example, blue. Maybe we want to change the thickness of a line. So line width, LWD, equals 2. Maybe we want to add a grid for better readability. We can do grid. Scroll down a little bit. I want the color of that to be light grey. We're going to have LTY equals dotted to make it a dotted line. And let's set the width of this line as well to something like 1. And if I run this, there we go. Now, maybe we want to customize the title of this plot a bit more. So what I'm going to do is actually remove it from this plot here. Run this again. And I'm going to do title. Again, we're going to call main equals, for example, depth versus chlorophyll A total. Then we can also change the size of our title, for example, by doing cex.main. Make that equal to maybe 1.2. And maybe we want to change the color of our title. We could do co.main and make that equal to dark blue, for example. We can also customize the axis labels. So I'm first going to set this equal to nothing here in the original plot to remove that completely. And I'm going to add them manually afterwards. So we're going to use this title again. And this time we're going to do xlab equals, for example, chlorophyll A in the units. And we can do ylab equals depth in meters. We can change the color of those labels. So for example, co.lab, make that equal to, dark red, for example. And maybe we want to make them a bit bigger as well. We can do cex.label and make that equal to maybe 1.2. And sorry, that was a typo, cex.lab equals 1.2. Now, we've overlain this because I plotted it once and then plotted it again. But after rerunning everything, there we go. And now, if we want to add the scatter point on top of that, we can do that as well. So let's use points. And again, on the x-axis is going to be chlorophyll A total. The y-axis is going to be depth. Let's make them red, for example. Let's have a look at that. Again, you can set the size if you like, something like cex equals 1.5. Again, I've double plotted them. I need to run everything. And maybe you want to fill them in. You can do PCH equals 19. Okay, so now let's move on to another example of plotting data over a map. So I'm going to clear almost all of this except for libraries. So in this case, we're going to use another OpenDAP URL. This is the NOAA Global Surface Temperature Anomaly data that we looked at in the previous tutorial. Then I can load that in with data open.nc and the URL. If I run each of those two lines, and let's take a look at the data with print.nc and data. Opening up my console now, scrolling to the top. This time we have this multi-dimensional data. And if I scroll down to the variable that we're interested in, this anomaly data, this has 4 dimensions: longitude, latitude, some vertical dimension, and time. But if we go to the dimensions at the top, z equals 1. So this is more or less just a 3-dimensional data set. So what we're going to want to do first is extract our data for the anom variable for a single time. And then we're going to plot those data on the map. And at the end, I'm going to show you how you create a function which takes only the time as an argument and creates a plot of the data. So you can quickly and easily execute that function for whichever time you want. Let's minimize this now. So firstly, let's get our latitude and longitude. So latitude, make that equal to var.get.nc. Data, which is our object, and our variable is called lat, which you can see here. Longitude, do var.get.nc again, data, and lon this time. I'm going to open up the console again and have a look at the time values. And you can see here that the units for this time are days since 1800. So each value is a float, which is basically a decimal number, instead of a long timestamp. So what we want to do is write some code that allows us to enter the date of our choice and extract the data for that date. So let's minimize this and do that. Let's say our desired date is equal to as.date and 2020-01-01. Now, I know that there is data for this date inside of this NetCDF file, and we're going to calculate the number of days since 1800 for that date. So we can use diff time to allow us to do that. Desired date and as dot date 1800-01-01. And we want that to be in the units days. So what this is going to do is calculate the number of days between our desired date here and the 1st of January 1800, which is the units of our time variable. So if I run that, now we want to extract our time values as well, so we can do time equals var.get.nc data and time. Run this. And now we want to find exactly where this value falls within this list. So we can do that by finding time index. So we're trying to find the index of where that value falls. Do that with which time equals, that should be 2 equals symbols. So basically, find the index where time is equal to this value. So I'll run that. If I reduce this, you can start seeing the values. And now we want to extract our data values. So let's do that. So let's call it anom var.get.nc data again. The variable is called anom in the NetCDF file. Now, this will extract all the values, but we want to just extract the data for that time. So we can do start and make that equal to C. I just want to have another look at this NetCDF file. Let's expand this. So the anomaly values have 4 dimensions: longitude, latitude, Z, and time. We want the data for every single longitude, every single latitude, the single vertical value that we have, and just our chosen time. So that order is going to be important. So I'm going to write here, let's move this up a bit, NA, 1 time index. And if we look at our anom value again, so what we're saying here is we want to extract the data for every single longitude, every single latitude, just the first and only vertical value, and starting from this time. Now, this is going to extract the data for every time after this. So then we also need to do count equals C, NA for every single longitude and latitude, 1 for just a single vertical value, and 1 for just a single time. So let's run that. Now, you can make a really quick and dirty plot of the data by just doing image, longitude, latitude, anom. I've just expanded this panel so you can see it a bit better. But that's pretty basic. So instead, I want to use ggplot. So I'm going to remove this line here. But to use ggplot, first we've got to extract the data to a data frame. So we can do df expand.grid lon equals longitude and lat equals latitude. And run that. I'll show you how that looks. We can see the data on this 5-degree grid. If I scroll down, you see the longitude changes first, and then the latitude. I'll close that. And to add our anomaly values to this, we can do df, $, and anom, which is going to be the name of our column, and make that equal to as.vector and anom, this variable here. So we'll run this and have a look at the data frame again. And we see it's been added. There are no values towards the poles. That's fine. If we scroll down, we can see that data has been added to the data frame. So closing this now and making a very simple plot with ggplot. First of all, let's do ggplot, plotting the data from this data frame. The mapping is going to be AES x equals lon, which is the name of this column header, y equals lat, and fill equals anom. And then I'll close this second bracket. Then I'm going to do plus geom tile and plus scale fill gradient 2. And within this, we're going to describe the color palette we're going to use, which is going to go from low values of blue for where it's cold. Mid value, I want to be white. And the high values, where it's hot, I want it to be red. We'll provide a midpoint and make that equal to 0. And we'll set the limits, make that equal to, for example, -10 and 10. Let's try and run that. And there we go. Of course, if we don't know what our limits are, we can take it as the minimum and maximum values in the data frame. So we could do, for example, min df $symbol and anom, and to max df $symbol anom. I'll plot that again. And there we go. Our colour bar is now a little lopsided, but our white values are still equal to 0. Now, without the coastlines and country borders, this is quite difficult to interpret. So let's add that on, the plus symbol at the end. And we can do that with geom polygon. Now we can say that the data we want is equal to map data of the world. The mapping is going to be like this, AES x equals long, y equals lat, and group equals group. I'll add this next bit to a new line. Let's set a colour for our borders and make that black. And we don't want a fill, so we can state NA. Let's have a look at that now. Now, you'll notice that something strange has happened. That's because our data ranges from longitudes 0 to 360, whereas the country borders range from -180 to 180. So we need to adjust our values. So back up here now, I'm going to create a new variable, longitude shifted. And we're going to use this function if else. And what we're going to say here is if our longitude is greater than 180, then this longitude shifted variable is going to be equal to longitude minus 360. And then else, so if longitude is less than or equal to 180, just make this longitude shifted variable equal to longitude. So if longitude is over 180, subtract 360 from longitude, and if longitude is less than 180 or equal to 180, just leave it as it is. So let's run this. Then we're going to have to update our data frame so that longitude is not equal to longitude, but is equal to longitude shifted. And if I run this through now, we can see that our plot looks much better. Now let's see if we can customize this plot a little bit more. Maybe we want to adjust the aspect ratio of the plot. We can do coord fixed and do ratio equals 1.5. There we go. We might want to remove this grey box. We can do that with theme minimal. I'm just going to reduce the size of this console so we've got a bit more space. We also might want to adjust the label on the color bar. So let's do labs fill is equal to temperature anomaly in degrees C. If that looks too small, you can just press this zoom here. That looks a bit nicer. And maybe we want to move that color bar to below the plot. So we could do theme legend dot position, make that equal to bottom. And that also looks a little bit nicer in our display. Now let's add a title to the plot. We can do GG title, and we can put anything we want here. So for example, temperature anomalies. But maybe we also want to include the date in this title. So we could do this dynamically. The date is this variable here, desired date. So we can use this function called paste within here, which will paste together our two variables. So pasting temperature anomalies to desired date. So if I run that, and there you go. Maybe you want to zoom on a certain region. So for example, I can do xlim and add a minimum and maximum longitude that I want to display. And I can do the same for the latitudes. So ylim, 35 and 75, for example. And if I plot this, now you can see we're just zooming in on Europe. So now, what if you want to create different plots for different dates? Well, what we can do is embed all of this code within a function. So that might be easier than you think. I'm going to scroll up to the top. I don't need to print this anymore. I'm going to create a function called plot temp anomaly. And that's going to be equal to function. And the two arguments I want to give to the function are desired date and the data. So every time I run this function, all I'm going to need to provide is the date I want to plot the data for and the data object. So when defining a function, we need to open some of these weird curly brackets, and all the code we want to include in this function needs to be within these brackets. So we can just copy all of this code from here. In fact, I'm going to cut that code out, paste it within there, make sure the indentation is correct, and I'm going to run this. All I've done here is define the function. And actually, I'm going to change this so I'm showing it for the whole globe. Make sure you run that again every time you want to redefine the function. And then to execute that function, all I need to do is call it. So plot temp anomaly. And I need to provide this desired date and the data. So I can just do as.date 1960 0101 and data. It's executed all of the code within that function and plotted it. Now you can see I've made one mistake. I've defined the desired date again within the function. We don't want that. So we can get rid of this line here. So I've made a change to the function. So I need to redefine it. And then I can execute it again. And there we go. And we can see, perhaps unsurprisingly, that there's a lot more blue on this plot. Maybe you want the range to be the same for every single plot. So perhaps you want to change this to between -10 and 10. This is a color range. Define that function again. Then we can plot this. And if we want to run it for a different date, we can just copy and paste below. Maybe do it for 1990. And again for 2020. And there you go. Again, you can access all the code, including this function, via a link in the description below. I hope you found this useful. In the next video in this series, I'm going to show you how you can extract the data from a NetCDF file and dump them to a CSV file or an Excel file. I'll put a link on the screen when that's ready. If you enjoyed this video, give me a like, post a comment below, and subscribe so you don't miss more content like this in the future. Thanks very much for watching, and I'll see you next time.